Natural Resources, Chapter 18, Energy Resources, Lesson 1. Sources of energy. Think about all the times you used energy in one day. You use it for electricity, transportation, and other needs. That is one reason it is important to know where energy comes from and how much is available for humans to use. Energy comes from the non-renewable and renewable sources. Most energy in the United States comes from the non-renewable resources. Non-renewable resources are resources that are used far faster than they can be replaced by natural processes. Fossil fuels such as coal and oil, uranium, which is used in nuclear reactions, and non-renewable energy source. Renewable sources are resources that can be replaced by natural processes in a relatively short amount of time. The sun's energy, also called solar energy, is a renewable energy resource. Others are wind, water, geothermal, and biomass. You will read more about renewable energy resources in Lesson 2. Non-renewable energy resource. You might turn on the lamp so you can read, turn on the heater to stay warm, or ride a bus to school. In the United States, the energy used to power lamps, heat houses, and run vehicles properly comes from the non-renewable energy resources such as fossil fuels. Fossil fuels, coal, oil, also called petroleum, natural gases, are fossil fuels. They are renewable because they form over 1 million of years. The fossil fuels used today formed from the remains of prehistoric organisms. Decayed remains of these organisms were buried by layers of sediments and changed chemically by extent.
Fossil fuels, coal, oil, also called petroleum, and natural gases are fossil fuels. They are non-renewable because they form over millions of years old. The fossil fuels used today formed from the remains of prehistoric organisms. That decayed remains of these organisms were buried by layers of sediment and changed chemically by extreme temperatures and pressure. The type of fossil fuels that form depend on three factors: the type of organic matter, the temperature and pressure, the length or time the organic matter was buried. Coal. Earth was buried different 300 million years ago. When the coal used today began forming, plants such as ferns and trees grew in prehistoric swamps. As shown in the figure below, the first steps of coal formation occurred when those plants died. Bacteria, extreme temperatures, and pressure acted on the plant remains over time. Eventually, a brownish material called peat formed. Peat can be used as fuel. However, peat contains moisture and produces a lot of smoke when it burns. As shown in the figure below, peat eventually can change into harder and harder types of coal. The hardest coal, alkali, contains the most carbon per unit volume and burns most efficiently. Oil and natural gases. Like coal, the oil and natural gases used today formed millions of years ago. The process that formed oil and natural gas is similar to the process that formed coal. However, oil and natural gases formation involves different types of organisms. Scientists theorize that oil and natural gases formed from the remains of the microscopic marine organisms called plankton. The plankton died and fell to the ocean floor. Their layers of sediment buried their remains. Bacteria decomposed organic matter, and then pressure and extreme temperatures acted on the sediments. During the process, the thick liquid oil formed first. If the temperature and pressure were great enough, natural gas formed. Most oil and natural gases formed where forces within Earth folded and tilted thick rock layers. Hundreds of meters of sediments and rock layers often covered oil and natural gas. However, oil and natural gas were less dense than these layers. As a result, oil and natural gas began to rise to the surface by passing through the pores or small holes in rocks as shown in the figure below. Oil and natural gases eventually reached layers of rocks through which they could not pass or formed under these impenetrable rocks. The less dense natural gas settled on top of the denser oil. Advantages of fossil fuels. Fossil fuels store chemical energy. Burning fossil fuels transform this energy. This step involves the changing of chemical energy and fossil fuels into electrical energy and fairly chemical energy and fossil fuels into electric energy are fairly easy and distinct. This process is one advantage of using these non-renewable resources. Fossil fuels are also relatively inexpensive and easy to transport. Coal is often transformed by trains. Oil is transported by pipelines or large ships called tankers. Disadvantages of fossil fuels. Although fossil fuels provide energy, using them has some disadvantages. Limited supply. One disadvantage of using fossil fuels is that they are non-renewable. No one knows for sure when supplies are gone. Scientists estimate that at current rates of consumption, the known reserves of oil will last only another 50 years. Habitat disruption. In addition to being non-renewable, this process of draining fossil fuels disturbs environments. Coal comes from the underground mines and strip mines. Oil and natural gas comes from wells drilled into earth. Mines, in particular, disturb habitats. Strip mining involves removing layers of soil and rock to reach coal. Forests can be fragmented or broken into areas of trees that are no longer connected. Fragments can negatively affect birds and other organisms that live in forests. Pollution. Another disadvantage of using the fossil fuels as energy resources is pollution. For example, runoff from coal mines can pollute soil water. Oil splits from tankers can harm organisms such as birds. Pollution can also occur when fossil fuels are used. Burning fossil fuels releases chemicals into the atmosphere. These chemicals react in the presence of sunlight and produce a brownish haze. The haze can respiratory problems, particularly in young children. The chemicals can also react with water in the atmosphere and make rain and snow more acidic. The acidic precipitation can change the chemistry of soil and water and harm living things. Nuclear energy. Atoms are too small to be seen with the unaided eye. Even though they are small, atoms can release large amounts of energy. Energy released from atomic reactions is called nuclear energy. Stars release nuclear energy by fusing atoms. The type of nuclear energy used on Earth involves a different process. Nuclear fusion. Nuclear power plants, such as one shown in the figure below, produce energy using nuclear fission. This process splits atoms. With a nuclear fission, processes begin when uranium atoms are placed into fossil rods. Neutrons are aimed at the rods and hit the uranium atoms. When hit, each atom splits the released 2 to 3 neutrons and thermal energy. The released neutrons hit other atoms, causing chain reaction of splitting atoms. Countless atoms split and release large amounts of thermal energy. This energy heats water and changes into a stream. The stream turns a turbine connected to a generator. As generator spins, it produces electricity.